Hi everyone, welcome to Manish IT. This is Manish. Today I am going to discuss about introduction part of linked list. See this picture. See this picture. From this picture, normally we are observing that it is looking like train. But I want to add something here. See this is the engine of this train, and these all are connecting. These all coaches are connected with the help of connecting hook. So here the role of engine is a head. Why I am saying like this? This is because of you all saw whenever engine of train runs, then all the coaches of train simultaneously run, and everything is controlled by engine. That's why we can say engine as a head of train. So and these all coaches are linked to each other with connecting hook. Same thing is happened in linked list. So let us start our topic. See, this is what? This is a snapshot of memory. Then memory is what? So memory is long tape of bytes, and each bytes having its own address. Suppose I am taking this segment of memory is extended left side as well as right side. So here I am taking address from 1000 for first block, for next block 1001, for next 1002. Similarly, it is incremented by 1 for character type. So see, this memory is a recursive resource in our system. We do not have a unlimited memory in our computer system. It is a responsibility of memory for which memory manager for which process and how much memory or how many memory has to be allocated, and which memory is free, like that. So see, suppose user has declared some variable, that is a int x. X is a variable that types of integer types. Then what's happened? So after declaration of this variable, memory has to be allocated for x with 2 bytes due to integer data type. I here I have assumed this compiler having 60-bit compiler, 16-bit compiler, but it varies in different compiler. So I let us assume it's having 16-bit compiler. Then its integer bytes is integer location memory is 2 bytes. So but thing is that now user want to add more than one element. That is, user want to add three integer value, and he is using array concept and created variable like this. So created variable like int array and 3. Size of array is 3. Then whenever this array is created, then it stores 66 byte of memory in integer type for array variable, and user has extended some values like 10, 20, 30. So how it's looking like this? See, its allocation of memory is started from 1011 to 1016, and it's allocating 6 bytes of memory, and user has already entered 10, 20, 30. So it's full allocation of memory, so its memory size is full. So its 10th location is 0, 1, 2, its indexing number. So we know that indexing number is started from 0, and it's going up to maximum size minus 1. So but here user again want to add one extra value in the same array and memory block without using any another variable. That means without creating any another array. So user wants to increase previous array size. Then what's happen? Question. Then what's happen if user wants to increase this array? So answer is, it is impossible to increase your size at the same time with same declaration in same memory block. So because of once array size is declared, Here array I have already declared array size is 3. So because of once array size is declared, then it can never possible to increase or decrease your array size from array property. Then thing is that user want to add one more element. That's why here we need to know the concept of linked list. So now linked list produce dynamically creation of memory in memory segment. That means whenever you entered any value, then memory will be created. That's why it is called dynamically creation of memory. So linked list is also collection of similar data type that is homogeneous and it has linear data structure, but its memory allocation may or may not be contiguous as compared to array, because of array having contiguous memory location 1011, 1012, 13, 14, 15, like 16. But in linked list it may be or may not be. So how memory segment for this block? So that's why I said like in array there is a contiguous memory location, but in linked list it may or may not be possible. So first see how we represent our linked list. So it's having see this representation of linked list. So it's having two part. One part is data part and another part is linked part. A linked part which stores address of another data part. So we will see it in it later. So here user has entered same value, because of I already told that the memory it is also collection of similar data types, then it's also memory is the segment of same segment. And see this first it's no its part is link part and data part known as node, as a it is a node. So why we can why I am saying like this, because of it's having two part, data part and link part, and it is separated by one another block. So that's why we can say it's simply it is a looking like node. So next our memory representation, because of it is also a similar it is collection of similar data type that is homogeneous. So it's definitely memory location is a long tab, long byte of tab. So here see uh, user wants to enter this same value in linked list. So then how it's looking like in memory segment? So see first user has entered 10, then second user has entered 20, then 30, and its memory address is like for 10 its address is 1000, for 20 its address is 1006, for 30 1012. So like that. So it is not contiguous. And one thing is that here point is that, but here we observe that every data having different address, and which is not contiguous location due to dynamically creation of memory. So but here we cannot correlate, here we cannot correlate from one data to another data. So question is that how we can traverse to each data. If you want to here you want to traversing from 10 to 20, then how it can be possible? So before uh, for answer this question, we have to implement these all values by logically representation of linked list using this node. So see how it's looking logically. So first we here I already told that a node having two parts, like one is data part and another is linked part, which stores address of next data part. So now suppose I already here entered like user has entered 10, so we stored 10 and their respective address is 1000. So see this here user has entered 10 and at their address is 1000. So next 20, so by logically we entered 20 and their respective address like 1006. So how we can correlate to each other. So we already told you this link part is nothing but it stores address of another node. So another node here for the respect of this node, another node is which one? This one. So this node having address is what? So this node having address is 1000, base address is 1006. So whenever first data link part, first node link part stores another node base address, then it is connecting its in between a bond is created. So see this how whenever when I have stored this address into this link area, then how it's looking like this. So see, when 1006 is stored in link part, then it is connecting to 20. So see this connection, and it is both are connecting to each other and correlated to each other. So next we having also another data. So see this we have to logical represent how to logically we know that. So after logical representation, it's having 1012 data base address. Its base address is 1012. Then what we have to do, similarly we have to follow that same rule. So we have to store this address value in this link part. So whenever we store this this base address in this link area, then it is connecting to 30 and it is correlated to 30. So see this how it's looking like. So after connection is over, so after we are correlating to each other. Each node is connected to another node, and it is correlated, each node having a relation. You can traverse by rule of linked list from beginning to last. But now user want to add another node, because of in array they are having restriction. Suppose here you have declare your size 3 and you want to enter some extra value, but in array it cannot be possible. But here in linked list you want to add some extra value, like user has want to enter 40. So then what's happened? So once answer is, it is easy to add any new data in linked list due to dynamically creation of memory. Now here user has entered 40, then see how it's looking in memory segment and how it's looking as logically. So after logically, it's also having address, that address is 1018. So after storing this when this link area stores this base address, then it is connecting to each other, and in between connection is created. So then after we have to we are traversing to 40. Still here we are traversing to 30, but from going to 40 we have to create our correlation in between two node. So the after create so we after storing this base address, we have to already we have created this correlated in between these all nodes. So see how it's looking like. So after creating correlated, it is connecting after storing this base address. It is connecting to this node and pointing to this. So now user do not want to end any further data element. So it is rule. We discuss a rule in next slide. But I told here, whenever user want to do not enter any value, then it is rule for linked list. You have to store in link area, that is linked part, null. Whenever you are entering here null, that means our compiler understand that no further element after this linked no, after this node, no any such element. So we have to store null after completing of our node. We have to store null. So here I am storing, I have stored null, so our compiler gets understand after this 40 element they are having no any elements because of its link area having null. So see, we have to suppose this all about introduction part of linked list. as we know as we know that every function having its own property, so see one by one. It's so linked list also a function, so definitely it's having also own property. See one by one. So linked list, so first property is what? So first property is it is a linear data structure, and second one is a linked list can be defined as a collection of variable number of data items. Next, an element of list must contain at least two fields, one for storing data and another for storing address of next element. And next one is, as we know, for storing address we have a special data structure of list. The address must be pointer type. And next, head or root, it is always pointed to base address. Next, in last node, linked part should be initialized with null. I already discussed in previous slide. Whenever you store null, our compiler understood no such elements after this node. So the next point is insertion and deletion in linked list is faster as compared to array stack queue. Next, in linked list, there is no wastage of memory. And next, it is impossible to create a static linked list that is fixed size. So I already told array having fixed size, that is array is declaring a static memory because of whenever you mention your array size, then memory is created for for that size. Memory is created that times. It is depending on you how value you entered. Suppose in previous case you entered you have created like array type and storing their size of array is 3, but I suppose as example array size, if any array variable having their array size is 50 and you are storing like only 10 integer value, then what's happen for after 40 whenever you created 50 memory block, then for that array that allocates memory like 100 bytes, and you have only entered 10 value, then it is consuming only 20 bytes, and 80 bytes of memory is that is wastage of memory. So in the linked list here, though there is no wastage of memory in linked list, but array having wastage of memory whenever you did not enter any value as whatever you are in slide array size. So next our discussion like types of linked list. So it's having like three types of linked list: single linked list, double linked list, circular linked list. Circular linked list having two parts, like single circular linked list, and second is double circular linked list. So single linked list having like a one having, that means data part and linked part, but its meaning, see this, it's double linked list. Double link, you see, double link means definitely it's having two link part. So see this, link part, and in between data part. So here it's me in the name of double linked list, it's clearly clarify that it's having two linked area. And circular linked area linked list, that means it's having two part, like single circular linked list, double circular linked list. So single circular linked list having two parts, and double circular linked list having three parts. So we will discuss in details in next videos. So see, applications, what are the applications of linked list? So first application, multiplayer games use a circular list to swap between players in loop, and in Photoshop, Word, or any paint, we use this concept in undo function. It is used in a famous game concept which is deck of cards. And fourth one, it is used in music playing system where you can easily play the previous one or next one song as many times one person wants to. Basically, it provides fully flexibility to perform functions and make the systems user friendly. So see this real time example of linked list. So this is the real time. We already discussed about brief discuss about this. So here we having two coaches, two coaches, and it is connecting with connecting hook. So this connection is nothing but in programmatically we can say that it is linking part. It is linking part to connecting to connection in between, or correlation in between two coaches after connecting this. So here you can see that when in I already discussed about this. So it is the real example of our linked list. So this thing is, if you having any question, then please comment in the comment box. And if really this video is helpful to you, then please share with your friends and subscribe my channel. So thank you for watching and listening my presentation.